Welcome back, 6th grade dragons. I'm on to equivalent expressions. We did some work with this in Carnegie, but it was rather brief. We did some sorting of cards and shapes, which was really an interesting activity. You might recall it. I have those cards here. We worked with these cards here. You might recall that the model matched the expression. This is the group when we did translating expressions. They were two different things. Now, in order to properly show you equivalent expressions, I'd like to do a quick demonstration first. Equivalent expressions means they're the same. The value would be the same. So let me start out with some algebra tiles to show you what I'm talking about. Let me use an easy example so I don't have to use a ton of tiles here. Let's say we're going to do something where we have a factor of 2 times a situation where it's 2x plus 2. Now here I will be applying the distributive property in just a moment. This is a factor. This whole thing is a factor. So when I use the algebra tiles, one factor is going to go on the left and one factor is going to go on the top side. All right, on the left is going to be the 2. Up here, 2x plus 2. That means I have 2 of these. Then 2 of these. Now the algebra tiles work like the area model. It's this side times this side. So 1 times x is x. It's an x. You have 1x. 1 times x, another x. Ditto here. Fit. And then this is 1 times 1 until we fill this in. 1 times 1 goes here. 1 times 1 goes here. 1 times 1 goes here and here. Because that's 1 times 1 there and 1 times 1 there. All right, let me zoom in on this for you. The outer edges. This is a factor here. This is a factor at this top line. This is the answer that's inside. Look at these. Think to yourself, what is this? How many x's? 4x plus, how much is here? 4. That would mean that 4x plus 4 would be the same value. I can prove that with the tiles, and I can prove that mathematically. So we just proved with the tiles that 4x plus 4 is equivalent to 2 times the quantity 2x plus 2. Now, if we were to apply the distributive property, you would see that this would be a true story, because we would do 2 times 2x, 2 times 2x, all plus 2 times 2. Now, when I work out these parentheses, I've got 2 times 2x, which is 4x. Bring down that plus sign. 2 times 2 is 4. Hey, it's a match. So here, mathematically, I applied the distributive property, and then here, I applied it using the algebra tiles. But either way, we've got the equivalent expression. So that means that this is the same value as this. Now let's fill out the interactive notebook page that correlates with this concept. Equivalent expressions. Equivalent expressions are expressions that simplify to an equal value when numbers are substituted for the variables of the expression. When they're talking about substitution there, they're saying if I make a value for x and put it into both expressions, I should get the same answer. We talked about that during class. I can prove it again here. Let's say x is worth 1. Well, let me take out this work in here. Let's pretend x is 1. We're going to pretend x is 1 each time. Well, here I would do 2 times 1 plus 2. So that's 2 times 2 plus 2. And you're going to add those. So it would be 2 times 4, which is the value 8. Okay, so this expression comes out to be 8. Let's try this one. X is still 1. We're substituting. We're proving that they are worth the same thing. 4 times 1 plus 4. Well, 4 times 1 is 4. Add the 4. Ta-da! 8. Therefore, this is equivalent to this, not only because we did it on the tiles, but we also tried it with the distributive property. Now we've done substitution and proven that if x is the same value substituted into each expression, you'll get the same solution. Examples on here. 2 times the quantity y plus 8 can be written as 2y plus 16 after distributing the 2. Therefore, 2 times the quantity y plus 8 and 2y plus 16 are, dun, 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 well, of course, they're equivalent expressions. You're asking yourselves, what is the point of this? The point is we can simplify it and make the expressions more concise, more consolidated, and when you do more advanced mathematics, you're going to want things to look as simple as they can. They make it easier to solve. All right, so here's some equivalent expressions they want us to investigate. If I have 3 A's, 1, 2, 3, invisible 1, invisible 1, invisible 1, you can put all the coefficients together and get 3A. So those have the same value. Now here, they distributed. They took care of 7 times x, which was 7x. Careful, that's subtraction. Subtraction. Then 7 times 4. 7 times 4 is the value 28. Here they did something called factoring. They said, who is a factor that can go both into 3w and into 21? Well, 3 can go into 3w, and 3 can fit inside as a factor for 21. So the greatest common factor between 3w and 21 is 3. So when you work backwards, this is the distributive property backwards. It's called factoring. You're going to pull the 3 out, create some parentheses, and then put the remaining factors inside the parentheses. So to have 3w, you must have done 3 times w. Subtract. To have 21, you must have done 3 times 7. So therefore, these are equal. Now, let's distribute these. We're going to do 4 times 2h. If you said 8h, you are correct. Addition, addition. Now distribute 4 times 5d. That would be 20d. That's a good job. Remember, this is one factor. This entire thing is another factor. Therefore, you have to multiply everybody in here by this guy outside here. Here's another one with coefficients that can be added together. 1, 1, 1, 1. How many n's do you have here? 4n. All right, so that completes page 18. I'm also going to go over a little bit of equivalent expressions in the Carnegie videos if you'd like to join me for those. The notes are mandatory, but the Carnegie is optional. Thank you again for joining me for page 18, and I'll be back in a minute for page 19.